Hello everyone. This is our Business Economics Take Home Challenges group assignment session. Now we are going to face these two challenges under game theory according to decision making under uncertainty and expected utility theory. These are our group members. Okay, let's start. Varuni, this is your chance.
Okay, what is the gameplay? Gameplay is the study of how to mathematically determine the best strategy for the condition in order to optimize the outcome. Gimhani?
Decision making under uncertainty. A decision making under uncertainty is when there are many unknown things and there is no possibility to know what could happen in the future to change the outcome of a decision. Expected utility theory. Expected utility theory is an explanation of how to choose rationally when you are not sure which outcome will pay off from your action, which means choose the action with the highest expected utility of decision maker. This is our first take home challenge. There is a ball. This ball has overall 9 balls. 3 are red balls and 6 are black and yellow balls. Decision maker doesn't know how many black and yellow balls there are, and other than there are 6 in total. The decision maker will choose one ball from the ball. Each ball is equally like to be chosen. There are 4 options. Option A is if decision maker choose a red ball, she can get 1000 rupees, otherwise 0. Option B is if decision maker choose a black ball, she can get 1000 rupees, otherwise 0. Option C is if decision maker choose a red or yellow ball, she can get 1000 rupees, otherwise 0. Option D is if decision maker choose a black or yellow ball, she can get 1000 rupees, otherwise 0. In these first two options, A and B, the decision maker selected A option, that is red ball option. She says she likes red balls more than black balls because it is known that there are exactly 3 red balls and the number of yellow and black balls are not certain. This is her personal decision. In this case, the preferences displayed by the decision maker are inconsistent with the principles of decision making under uncertainty and expected utility theory. Here's why: violation of the principles of independence, inconsistent utility assignments, and ignoring available information.
Thank you, Gimhani. Here, there is a higher probability of picking black or yellow ball than a red ball because there are more of them in a ball. There are only 3 red balls in the ball, but there are 6 ball yellow or black ball. Looking at the probability here, A option probability is 333.33 and B option probability is 666.67. Example: A option probability: calculate 1000 over 9 multiplied by 3 equal 333.33. B option probability is 1000 over 9 multiplied by 6 equal 666.67. Here, although there is more probability for B, but the decision maker prefers option A. It depends on his choice, but is not best options. Thank you.
Thank you, Ashna. The conclusion is all things considered preferences may not be the best choice. So it is important to consider the probability. Finally, this inconsist in the preferences violate the preferences of extinct utility theory, which stated the preferences should be transaction and concession in the case. The decision-making preferences are not transition made that inconsist with the best of decision-making under the uncertainty.
Thank you, Varuni. Now let's go to the second question. We need to show that no players has an intention to deviate from the chosen strategy. Player 1 vote for A player, player 2 vote for A player and player 3 vote for A player. The utility obtained by each players in this profile is as U1 AAA equal to U2 AAA equal to U3 AAA equal to. Yes, continue to Sati.
Thank you, Summery. If all players vote for A, then A wins and each player receives a utility of 2. Since no players want to change their vote because they already have the best outcome, so AAA is a Nash equilibrium. Next one is we need to show that no players has an incentive deviate from the chosen strategy.
Yes, City. Player 1 votes for A. Player 2 votes for B. Player 3 votes for A. The utility obtained each place in this profile is as utility 1 ABA equal to 2. Utility 2 ABA equal to 1. Utility 3 ABA equal to 2. Now continue, begin.
Thank you, Madhusha. Player 1 and 3 receive utility of 2 when they vote for alternative A. Player 2 receive utility of 1 when they vote for alternative B. If any player were to change their strategy unilaterally, they would get a lower utility and thus they have no incentive to deviate. So ABA is also Nash equilibrium. Continue to Esha.
We need to show that no player has an incentive to deviate from choose strategy. U1A equal to U2A equal to U3B equals 0. In this case, player 1 and 2 receive a utility of 2 when voting for alternative A. Player 3 receives a utility of 0 when voting for alternative B.
Player 3 can see that if they switch their strategy to waiting for alternative A, they will get a higher utility. Therefore, player 3 is incentivized to divide from their strategy and change their vote to A. Since at least one player has an incentive to change, their vote is not equilibrium. So ABB is not Nash equilibrium.